If the universe is this big, where is everybody? There are an estimated 200 billion trillion stars in the observable universe. Around a huge number of them, planets, rocky ones with water, ones sitting in exactly the right orbit to have liquid oceans and stable climates, the same conditions that on at least one small planet gave rise to life. And yet, as far as we can tell, we are completely alone. No signals, no probes, no visitors, not one confirmed trace of anyone else, anywhere, ever. That silence has a name. Scientists call it the Fermi Paradox, and the more you understand the numbers behind it, the stranger that silence becomes. In 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos. The conversation had drifted to aliens and UFOs, a popular topic at the time. Then Fermi reportedly paused and asked a simple question. "Where is everybody?" He wasn't being dismissive. Fermi was one of the sharpest minds of the 20th century, a man who helped build the first nuclear reactor. He understood scale, and when he ran the numbers in his head, he realized something unsettling. If intelligent life is even moderately common, the galaxy should already be full of evidence of it. Old civilizations, radio signals, probes, something. Instead, silence. Total, complete silence. That gap between how likely life should be and how little evidence of it we actually have is the paradox. It's not really about aliens showing up in flying saucers. It's about a mathematical expectation crashing directly into an observed reality that doesn't match it at all. Let's build the case for why we'd expect company. The Milky Way alone has an estimated 100 to 400 billion stars. As of the early 2020s, astronomers had confirmed thousands of exoplanets, with thousands more candidates awaiting confirmation. And the data suggests that Earth-sized rocky planets, some sitting in the habitable zone where liquid water could exist, are common, not rare. The Milky Way is about 13 billion years old. Our Sun is only about 4.6 billion years old, meaning there was plenty of time, billions of years, for other stars and planets to form, develop life, and evolve intelligence long before Earth even existed. Here's the part that makes it eerie. Even without faster-than-light travel, a civilization using slow, sub-light speed spacecraft, even taking centuries per journey, could theoretically colonize an entire galaxy in something like 5 to 50 million years. That sounds long, but on a 13 billion-year timescale, it's a blink. A single early civilization, starting just a few million years before us, should have had more than enough time to spread across the entire galaxy. So the expectation is, the galaxy should be old, it should be full of viable real estate, and it should have had enough time for someone somewhere to expand into all of it. And instead, we see nothing. No megastructures, no signals, no probes, no visible modification of stars or galaxies by advanced civilizations. Nothing. That gap is the entire paradox in one sentence. The universe is big enough and old enough that it should be loud, and it's silent. In 1961, astronomer Frank Drake tried to formalize this problem into an actual equation, a way to estimate how many communicating civilizations might exist in our galaxy right now. It multiplies together several factors: the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, the fraction where life actually develops, the fraction where that life becomes intelligent, the fraction that develops detectable technology, and finally, how long such a civilization would survive and keep broadcasting before going quiet. Depending on which estimates you plug in, you can get an answer of, we should be one of millions of civilizations, or we might be the only one in the observable universe. The equation doesn't solve the paradox. It just shows you how wide the uncertainty really is. The problem with the Drake equation isn't the math. It's that we barely know most of these numbers. Some terms are becoming more measurable thanks to exoplanet science. Others, like how often life becomes intelligent, or how long technological civilizations tend to survive, are still almost pure guesswork. This is where it gets genuinely unsettling, because every proposed solution to the Fermi Paradox falls into one of a few categories, and none of them are especially comforting. 1. We are early. One straightforward possibility: intelligent life is real and common, but the universe is still young in the grand scheme of things, and we happen to be one of the first civilizations to arrive. Star formation will continue for trillions of years. Our current era might just be the opening minutes of a very long story, and we're one of the first guests to show up. 2. The Great Filter. This is the darkest and most discussed explanation. The idea, somewhere along the path from lifeless chemistry to galaxy-spanning civilization, there's a barrier, a filter, that almost nothing gets through. The unsettling question is whether that filter is behind us or ahead of us. If it's behind us, if the hard part was something like the origin of life itself or the jump from simple to complex cells, then we've already beaten the odds, and the future could be bright. But if the filter is ahead of us, if it's something like nuclear war, engineered pandemics, runaway artificial intelligence, or ecological collapse, then the silence we hear from the universe isn't good news. It's a warning. It might mean that every civilization that reaches our level of technology eventually destroys itself before it can spread to the stars. 3. The Dark Forest Theory. Borrowed from science fiction, but taken seriously by some scientists. Maybe the universe is full of life, but everyone is hiding on purpose. The logic goes like this. In a universe where you can't be sure if another civilization is friendly, broadcasting your location is a huge risk. Any civilization advanced enough to threaten you could also be advanced enough to wipe you out from a distance, long before you'd even know they existed. In that environment, the safest strategy for every civilization is the same. Stay silent, stay hidden, and treat any signal you detect from someone else as a potential threat. Under this theory, the silence isn't because no one's out there. It's because everyone learned to stop shouting. 4. We're looking in the wrong way or the wrong place. It's possible advanced civilizations don't communicate using radio waves at all. The technology we've been listening for since the 1960s might already be primitive and obsolete to anyone sufficiently advanced. Or they may be using directed, tightly focused signals rather than broadcasting outward in all directions, meaning we'd have to be pointed exactly at them, at exactly the right moment, to notice anything. We've also only seriously searched a tiny sliver of the sky for a tiny sliver of time, using instruments that are still fairly limited. Absence of evidence in this case might not mean much yet. 5. Civilizations don't expand, they turn inward. Some researchers suggest that sufficiently advanced civilizations may lose interest in physical expansion altogether. If a civilization masters simulated or virtual environments, or radically extends its lifespan through technology, the incentive to spend enormous resources colonizing other star systems might simply disappear. Why cross the galaxy in a slow ship when you can build a perfect universe of your own at home? 6. We really are alone. The simplest, and in some ways the most extraordinary answer. Maybe the specific sequence of events that led to intelligent life on Earth, a stable star, a moon that stabilizes our axial tilt, plate tectonics, a series of survivable mass extinctions, and billions of years of uninterrupted evolutionary time, is so improbable that it essentially never happens twice. Under this view, life might be common in some simple form, but the leap to intelligence capable of building a civilization might be the rarest event in the observable universe. If that's true, we're not just a species on a planet. We're the only known instance of the universe becoming aware of itself. Whichever explanation turns out to be closer to the truth, the Fermi Paradox forces an uncomfortable reflection back onto humanity itself. If the great filter is ahead of us, then how we handle the next century, nuclear weapons, artificial intelligence, climate stability, pandemics, isn't just a policy question. It might be the exact test that every silent civilization before us failed. If we're simply early, then everything we do now, every signal we send, every probe we launch, could be the first chapter in a story that plays out over millions of years, watched eventually by civilizations that don't exist yet. And if we are, genuinely alone, the only thinking minds in the entire visible universe, then that changes the moral weight of everything we do. There's no cosmic backup, no other civilization coming to carry the story forward if we fail. Whatever meaning, art, memory, or knowledge humanity generates, we might be the only place in the universe where any of it is happening at all. So, where is everybody? The honest answer is, nobody knows. Not really. What we do know is that the silence itself is data. It's not nothing. It's one of the strangest and most important observations humanity has ever made about its place in the universe. Maybe we're early. Maybe we're rare. Maybe everyone's just hiding. Or maybe, and this is the version that should keep you up at night, maybe there's a wall up ahead that every civilization eventually hits, and we're about to find out if we can get past it. If you had to guess, which explanation do you think is closest to the truth? Leave your theory in the comments, subscribe for more.